where f is, I'm going to draw an arrow like that to represent increasing, right? So part A, I'd like for us to find where the function is increasing. Does that make sense to you if I draw the arrow like that? F is increasing. Next, I want us to find where this function is decreasing. And then for part C, I want to find any local maxes or mins. I'm trying to find where this thing has peaks and valleys, right? Do I have a closed interval?
No.
No. So we are now doing open interval method. All right, this is now going to be the open interval method. All right, so what I'm looking for here to figure out local maxes and mins, I need to figure out where my derivative goes. My derivative is going to be positive, which means my function goes up and then goes down, or where it goes down and goes back up, right? So the way I'm going to do that is first I need to know what the derivative is, right? Let's go take the derivative. What's the derivative of this function? I made it a nice one for you. 4x cubed minus 12x squared. There's our derivative, right? I would like to know when this is positive and when it is negative, right? That's what I want to know, because wherever that's positive, I know that, let's make this connection. Wherever this is positive is where that one's going up. Wherever this is negative is where that's going down, yes? So the way that I determine whether or not this is where that's going up and down is I'm going to first start with the critical numbers of this. And how do we find the critical numbers? Set it to 0, figure out where it doesn't exist. Let's do the doesn't exist first. Where does that derivative not exist? Well, it's a polynomial, right? So do we have problems? No, so I can just chunk this, I don't need that. But setting it equal to 0, I will have to solve. And now just, what, GCF? Let's take a 4x squared out. That leaves us with x minus 3. And now, using the 0 factor property or whatever, set those both equal to 0. And you get two solutions, 0 and 3. Are those in my, well, wait a minute, there's no interval, right? But we do want to make sure, are those in the domain of the function? Yeah, they're in the domain. I mean, I can plug 0 and I can plug 3 into those, yes? Y'all good? Doesn't this look familiar so far? I mean, we found the critical numbers. Here's where things change, all right? I know it's the end of class. We've only got a few more minutes. Okay, please, let's try and see if we can not lose this because it'll haunt you. What I'm going to do now is different than anything we've done. I'm going to now draw a number line. And I'm going to plot my two critical numbers on it. And I'm going to use those two critical numbers to partition my number line here into 3 sections. And what I'm going to do is like I said a second ago, I would like to know where this is positive because that would be where that goes up. I'd like to know where this is negative, which means that's where that would go down. So the first thing I've figured out is where it's 0, right? These 2 points, this is where my derivative is 0. So now what I'd like to know is to the left of this, what is the derivative doing? Is it positive or negative? Here is the derivative positive or negative. Here's the derivative positive or negative. So I'm now going to pick test points, and those are up to me. I just got to pick something to the left of 0. I like to do test points with little x's, and I circle them as well, -1. Something in there? 1. Could you pick 2?
Yeah.
Could you pick 2.79625? Yeah, whatever you want. Yeah. 4. Notice I put x's and circled them. That's so I don't confuse them with my critical numbers. Now, what do I want to know? What the derivative is doing, right? Is the derivative positive or negative? Right? Is the derivative positive or negative? So I'm going to take these three numbers and plug them into the derivative, not into the original function. That's closed interval method. That's something else. You're testing endpoints. Closed interval method, we don't do test points, right? So let's take these and plug them into the derivative. So now testing f prime, right? So let's go f prime and let's plug in -1. Let's go f prime, let's plug in 1, and let's go f prime and plug in 4. Into the derivative, right? Into this. Into this. I've got to move quick here. -4 minus 12, you get -16. Plugging 1 in there, you get 4. Take away 12, that's -8. And then if you plug in 4, you get a positive number. I'm not even going to calculate it, but it's positive. What am I looking for here? What matters to me in these three answers? The sign, whether or not it's positive or negative, right? The fact that the derivative at -1 is negative, right, over here, the fact that the derivative over here is negative, what does that tell me about the original function? What is it doing over here? Decreasing. It's decreasing. It's going down. My original function must be going down over here. See, I'm making like a little table of information. I know that at -1 my derivative was negative. A negative derivative means my original function is going down. Now what's happening at 1? It's negative still, right? So if my derivative is negative here, what is my original function doing? Still going down, right? Decreasing. And then finally, when I plugged in 4, my derivative was what? Positive, greater than 0. And what does that tell me my original function is doing? Increasing, going up. So by looking at that table, can you now answer part A? Can you tell me where this function is going up?
Yes.
Where?
On the left.
From 3 on, right? How do we say that? I'm going to put it in different colors so you can see it. So I'm answering questions now. Part A. For increasing and decreasing, I will always use parentheses. And I suggest you do. I don't know why I put -3 there. Sorry. It would not be wrong to put brackets, but it's also not wrong to put parentheses. I recommend parentheses just because later on there might be problems with some domain issues at the endpoint. So, okay, where's it going down?
At 0, well, 3.
Here, right? But isn't it like implied that this is always this way?
Yes.
So -infinity all the way to 3. You don't have to worry about it at 0 because it's still going down. So -infinity to 3. Almost done. Almost done. Any questions on those? Where it's going up and down, we're talking about x values. Okay? These are x values where the function will be going up and down. Now, do we have any local maxes? What are we looking for a max? As we read it from left to right, we'd be looking for what for a max? Up and then down. Do we ever see that? No, which means we have no local maxes. Right? Local min, we're looking for down, then back up, right? And we have that where? At 3. So it's happening at 3. Do we know the value?
No.
How do we get it? Plug 3 into the original function. So I'm going to answer that right here. So I have a local minimum at x equals 3. To find the value, we take 3 and plug it into the original function so that we can get the y coordinate. And if you plug 3 in there, you get 81 minus, 27 times 4, 108. That doesn't seem right. 108? I don't know why that seems odd to me, but okay, plus 1. What do you get? 36? 26, -26. Okay, thank you. -26. That should be our local minimum value. While y'all are absorbing that. We have 1 minute. I'm going to graph it. The answer would be your, I would take the point or just the y value. Either one is fine with me. So I'm just going to graph this. X to the fourth minus 4x cubed plus 1. And go to the standard graph. There's the graph. I'm going to kind of change the scale there. And if we go to the point 3, negative 26, that's that point. I mean, do you see what we just did? Y'all see the graph over here? We just found where that graph was going down, right? It's going down to the left of 3. To the left of 3, the graph is always going down, right? To the right of 3, the graph is going up. We don't have a local max, but we have a local min right there. See? Did all that without graph. So the question is, why don't we just do that, right? Just type it in. We already talked about that, right? Somebody's got to know how the wheels turn. Okay, everyone, do your homework. Don't get behind. We don't have many classes left, right? So
Is our test on Thursday?
the test, there's no test on Thursday.
Or next Thursday?
Next Thursday, I don't know. I think we might have to keep it there. I don't know. I don't see pushing it to Tuesday. Do y'all think we should do it Tuesday? When? I know, I think I promised it, didn't I?
Yes.
Yeah. No one emailed me or texted me or about it. Like, where's that review you promised?
If we're getting a review, I would like to have it over a weekend.
Yeah. Okay, let's just do an informal vote. How many of you want to keep it for next Thursday? Okay, move it to next Tuesday. And I think that's, yeah. Okay. Yeah. I'm going to give you the review. I'm going to try and do it tonight. I have something ready to go. So let's just keep it at Thursday for right now unless something dramatic happens. All right? Okay, everyone. Do your homework. Don't fall behind. It's very easy to fall behind right now because we're rushing. Let me turn the camera off real quick.